Hello everyone. Okay, and what's up, Derek? Unfortunately, we're not quite at the water shader stage, but we're closer than we have ever been, I would say. So, we're in the process of... So if we take the fluid solver consists of two while loops, basically, or iterations, multiple iterations, and after each iteration we want to show the result, and this is going to be a little bit tricky since we're threading the iterations. So that's what we're in the process of doing. So it all comes down to the fact that we want to continuously we want to give feedback to the player what exactly is happening with the fluid simulation. So one could think the most easy approach would be that the player adds water to a point, we start a second thread that calculates everything, which can take quite a while, and then we show it to the player. But then the player doesn't get any visual feedback of the process, so the player doesn't know when to quit and whatnot. And we're in the process of splitting up the fluid simulation in natural chunks so we can show visual feedback in between those. So do some work on a secondary thread, show animations to the player and as soon as one iteration is done of the fluid simulation, we represent that in the game world. This might sound weird, but it's both less and more complicated than I assumed. This task system that is available in C#, extremely nice and easy to use, but how to split up the algorithm, a little bit more tricky. Yo, what's up, PG King? Good morning, good morning. So yeah, this is pretty much how we split up the algorithm. And here we have it. So when we add fluid, we do this. If it's running, if we already have a solver running, we just return. If not, we set is running to true, and then we start it. And at the end of last stream, we added this try catch and finally block. And it's basically done like this because within this try, we're gonna start a lot of tasks. Some of these tasks are gonna have a cancellation token. So for instance, while we're running this task, we might send it a message that it should cancel. And if it cancels, we want to do something. And then finally, we want to do this. I want to try this and make sure that it works as well. Although I wonder, can we do it now? Let's try it real quick. What would happen if we played now and canceled it? So if stop add fluid async is called and we are running, we call or we set fluid solver token source. We call cancel on this token. If we're in this method, we will quit. If we're in this one, we won't just yet, same, and so on. Ooh. We might want to add an extra check here. If we're running and this one is already set to cancelled, we don't want to call cancel again. But okay, the idea is then that find reachable minima, we need to add a check here to make sure that it cancels correctly. Unvisited points. we could basically do it like this. So in this while here, we could add an extra check, and if that and we check if the token has been cancelled or if a cancel has been invoked. If so, we will quit this while loop. We will still do this, and I'm 100% okay with still doing this. I also want to do this, and we want to do this. But what I'm a little bit afraid of is if we do this block and then cancel is called, what happens then? So then we do set value water temporary. I think it should be okay. This might look a little bit weird. We're actually going to clear water temporary data as well. That might not be the best option. Or actually it's okay. It's 100% okay. Okay, beautiful. So let's take a look here. Sharp cancellation token, or there we have it. So I wonder, or this is what I'm not entirely sure. Yeah, we want to throw this one. So it's pretty much going to be something like this. And what did we call it? Fluid solver token source. Pretty long name because we need to do this as well. So we do this while we still have points to visit and minima hasn't been found, and fluid solver token source token cancellation is not requested. And finally, I always want to do this. So let's say that we exit the while loop and then we do this. And then we quit. So if or actually no, we need to check this and then we want to throw. Okay, so if something, then we do this. It's very important that we do this because this one sets, this does, or this part basically helps us or sets the data up in such a way that we can visualize this. Because even though we're ending the fluid simulation, I still want to visualize this step. I think we're probably going to move this one around a few times before we reach something that aligns with the vision I'm having. So with this in place, this one can be cancelled midway through. So if this one throws an exception, we won't continue down here. Although I wonder, Yeah, the better option might actually be to have this one. So if we cancel it here, we don't actually want to visualize the latest loop here. So maybe this is better. Find reachable minima. So if we cancel in this one, we haven't changed water, which means that water should be equal to whatever it was previously. Move data water to water previous. Yeah, okay, so here I want to switch data. We want to implement some swap data. Actually, we might have already done that. Controller, terrain, swap data channels, and we do terrain data type. We want to swap water with terrain data type water previous. So it's basically going to be like this. This is finding the minima. So we do that part, we iterate that part of the algorithm. If it gets cancelled, or if it doesn't get cancelled, okay, so if it doesn't get cancelled, we never set it's running to false. I wonder if we want to do this actually. Or not yet. Yeah, this one might actually be... No, let's do it like this for now. So we basically, as soon... If we exit during this one, we will jump down to this, put whatever we had in water previous in water, and call it a day. But if this one runs its course, then we have another issue. So I wonder if we want to do this for now. What do we have? Let's just do await task.delay. And we send in fluid solver token source token. Or do we have something better? Task dot. Let's take a look. Beautiful. So we just do wait. Do we have that one in this version? I hope so. Fuck. Oh, we can only do this on a... Where do we have... Delay is static. Do we have delay without... Delay with only cancellation token? is a very special case. Let's just do delay with int max value. Like, this is definitely not what we want to do in the end, but I haven't really figured out how to handle this one. Like, we have the big question still. Should this task only be able to be cancelled by the player, or should we add a second way of cancelling it, and that way being we have reached an end state and can't proceed with the algorithm? It was a question I raised for the first time yesterday, I think. And I'm leaning towards having two ways of exiting this method. So the method itself and player input. Because I don't really like the idea. We are gonna get to a maximum amount of water added to the terrain, definitely. Like, we can't add infinite amount of water. So it's just a question of how I want to visualize that information to the player. Do I want the player to just loop the water pouring algorithm indefinitely, or do I want the character to stop adding water when there's no more to add? I want to avoid a scenario where the player thinks he or she is adding water, but nothing is actually happening. So yeah. We could also add, I didn't think about that, but yes. We're probably gonna add some sort of visualization. So I'm thinking of a scenario where, let's say that the terrain is just full flat, the player starts to pouring water. Thanks to putting most of this logic on a secondary thread, we could actually go on and fill up the whole terrain with a small amount of water. But it will take extremely long and we might not need to handle that scenario. Instead, we could let finding a minima algorithm have a maximum amount of spread it can have, and quit early here as well. But yeah. Okay, so the big question here right now is, will this work? Sure as hell hope so. Move data water to water previous. We still want to do this. Yeah. And this is really good. So after all of this, we finally do a swap data channels. We might do some previous work here. I wonder... Move data water previous to water. Yeah, we definitely want to do. So what we do right now is that when we stop this task, we just revert to how it was previously without no additional changes. So it's basically just going to reset the water level to be water previous. And I think that's good for now. The last thing I want to do is I want to check the cancel here. One sec though. We might get stop add fluid async. Action terraform. What do we have? Stop processing. If terraform routine, we stop it. Otherwise we do stop add fluid async. This one, we want to override try stop processing, definitely, I think. Yo, what's up, Calvino? Good morning, good morning. So if this one fails, which it can, like if we're not running, then it should probably return true though. It's just a question of the communication from the player to the simulation and simulation to the player. But what we would like to do is probably to override try stop processing. Stop processing. Yeah, we want to do a second check here. Is this actually the first action I have where a try stop processing can fail? Feels a little bit weird. But okay, before we worry about that, I do want to check what we have here. So I'm not gonna push this one to its limits, but here we want to check if this one has already if we already have a cancel here. I wonder if we can do it by this one. Right, we should be able to do it like that. So if it is running and token cancellation hasn't been requested already, then we request a cancel. Otherwise we skip this. Let's try it and see what we have. It should pretty much work exactly as it previously did, but we have just improved, or we have reorganized and redone the code in such a way that we can extend it. Let's see. And then we do this, and we just wait indefinitely here. So if I cancel this one now, it cancels. But if I add water, fluid solver cancelled. Okay, I'm a little bit worried about that one. Oh yeah, 1 sec. It works once, but here's the thing. I want to be able to reuse this token, so after we have cancelled it once, like when we get down to here, we pretty much want to reset it, because as it's implemented now, it's a one-time use token. We never set back the state of it, so we can't really add more water after the fact. So what do we have? Okay, so if we jump to cancellation token source, cancel after cancel async, create link token source dispose, try reset. What do we have? Attempts to reset to be used for an unrelated operation. Returns true if the cancellation token has not had cancellation requested and could have its state reset to be reused. Okay, so why? Let's see why it can fail. Yo, what's up, No Core? How long have you been working on this game? I think you can check on my YouTube channel. I started doing devlogs when I first began working on the game. So I think I did my first devlog in, was it 2021 March? But that was just a devlog describing the project. The first time I started writing code for it was at the end of 21. And I started working like half-time this year. Yo, what's up? I'm me. Hope you had a wonderful summer. Although I don't agree at all with what you're saying. This is what it is, making a game. Calvino, October 3rd, 21. That is devlog number 1. Then we have devlog number 0, which is just like describing what I will be trying to make, I think. No Core, wow, congrats for sticking with it for so long. I don't know if it's... Yeah, maybe it is. Thank you. Yeah, devlog 0 was March 24. That was when I had the initial definition of what kind of game I wanted to make and had started writing my design document. That is true. Yeah, it is quite a while. But like, I've been wanting to make this game for way longer. So it hasn't really been a problem sticking to it, because this is a game I really want to make. Okay, so this one can fail. When it is known that the operation with which cancellation token source was used has completed, no one else will attempt to cancel it, and any remaining registrations are erroneous. The fuck is this? Me Greybox comes first. Yeah, that's what I used to think as well, but I want to get some reach for this game before that point, and you won't get any reach with gray boxes. So yeah, if it was developed behind closed doors for a long time, yes, then gray box logic first. It's new times, man. No Core, that makes sense. I keep jumping from game to game, never finishing anything. Yeah, I used to do that as well. Like when I got a game idea, started making it, and eventually like I ran out of motivations because I didn't really believe in the game idea. So I've been there definitely, but this is like a dream game of mine which I've thought about for a long time. So I really want to make this game, if that makes sense. As long as there is some kind of motivation, something will be worked on, definitely. But I've also learned that to not rely on motivation too much and rely on discipline more. But since this is my dream game and I really want to finish it, I have this tiny motivation in the back of my mind at all times, so that's definitely true. I mean, it makes sense, but I've been there. Yeah, I know. I mean, it's a big question, and I can see both sides of it. Should one do, like, implement the full game logic in such a way that it is fun before one starts adding visuals and making it into a game? There's pros and cons to that. Or should one, like, develop the game logic and the visuals in parallel? I'm pretty sure I won't end up with nothing. And I actually have a deadline now for the terraforming part. Calvino, that's why I don't work as much on my hobby game, because I don't take the time when I don't have motivation. Yeah, definitely been there as well. Like, I think I should give credit where credit is due, but there was one indie game developer which had a full-time job and made a game on the side, something with a fox, or Lone Tree, I think. And he had this rule that every day he was going to do something with his hobby game. Like, it doesn't matter how big of a task, just something small. It might just be fixing the visuals of a tree or something. And, like, which usually led to him sitting down at the computer, opening up the modeling software, fixing this tree, and then just continue. Like, so it was like his trigger was to just try and do one small thing each day. Yeah, if you always do something, you move forward, or sideways at least, definitely. Okay, I think we can pretty much we can use this one without second thought, because all of these are true. So after all of this, let's see here. Yeah. Fluid solver token source try, or is it actually the token? Try fuck, I'm starting to wonder. I'm starting to wonder if we're not on this version, and that would suck. Mm-hmm. Let's see, I want to see, do we have some information of what version? Oh, why can't I use this one? Cancellation take token source. System threading. I have no idea. Okay, so that's unfortunate. Okay. So I guess like an easy fix or an easy way to get around this is just to instantiate this one or reinstantiate it. But that doesn't feel very clean. But let's do it. I don't get this. But actually, okay. Water temporary, we don't reset it, so that's good. Okay, I think we have it. I wonder. Yeah, okay, this is good. So I think we're starting to be ready for introducing the second loop for this fluid solver. The question is, I'm pretty sure we are, but I want to I just need to think here. Will we be able to do this with only the channels we have or the data slots we have? Because I'm thinking that like water and water previous, we always want to keep these synced in a way. Like the shader is always going to interpolate from water previous to water based on timestamps. But starting to think that that might be harder than I initially thought, because terrain data type water previous. So we always need to have, like worst case scenario, we always need to have exactly how the water previous looked before this. If all of this fails, we want to be able to revert. Currently we can do that, but should be okay. It should be okay. Yeah, we're gonna have to be real smart about the timestamp later on, but I think it's okay. And keep it in mind in the second while. I'm actually gonna add a fluid unit dry constant public static, or I can do int Okay, step 2 then. Find reachable minima. This one we have already fixed. Calculate stable fluid state. So what I'm thinking here is unvisited points, affected points. Affected points we're gonna keep. Oh shit, 1 sec. Definitely don't want to delete that one. So calculate stable fluid state. We're gonna alter this method a tiny bit. So we do want to make it spread fluid, but the main purpose of this method is going to be calculating new fluid amount. That's all it's gonna do. So we're gonna spread more and more water. We're gonna visualize it. We're gonna visualize overflow as well, but behind the scenes we're always gonna calculate the variables that will help us define the stable state, so we can revert to that as soon as this fluid solver has been cancelled. So affected points, this one we already have, yes. Actually, one sec. Yeah. Yeah, we can simplify this one a lot. We only care about one minima. So final points here, we can change this one to, oh yeah. So we're gonna do, what do I want to return here? I think we want to return not a list, but we want to return no, we just want to return a float, and that float is going to be new fluid amount, because this is the fluid amount we're eventually gonna fill it with. And then we can change final points. We don't need to send in final points. We just send in one terrain fluid point M. That's our minima. And let's see. Unvisited points we need. I don't care about this one. Alter data. We move water temporary to water, and we do this. I don't think we need to do this anymore either. So let's take a look at, so if we find a minima, we recalculate fluid mesh data, we update fluid mesh, we delay a bit, we add to fluid amount. Not too sure about this one just yet. That's, maybe it's okay. And then we move data water previous to water. And we move water to water previous. I don't think we want to do this. Actually. Or actually, we do. But then again, yeah, depends on how we want to visualize it. Probably work with it. I'm thinking, so here we do actually change water, but I think that's okay. Move data water to water previous. We don't clear it. So this one might be I think we're gonna do this. So for the first time, this one will be quite idiotic, but that's okay. And then we're gonna do fluid amount. We're gonna put this one here and do this. And then also one last thing. Yes, fluid amount, we're gonna set this one to 0. So we do this first instead, so which means that if we have found a minima, we don't do this step. Yes. Okay, let's see, what more do we have? So controller, alter data, no. This one we already do. Previously we do this one as well. I don't know what the hell was going on here. M height, M water, We don't need to store these anymore. This one I still want to do. Lowest unreachable height, max value, highest point 0. I do. Actually, let's do. Okay, we're simplifying this quite a bit right now. So let's see. Unvisited points first, P height. I don't know if we want to store these or save these. Okay, we want to figure out the highest point because we use it down here. P. Highest point. Max. One sec. We do a mathf max of lowest unreachable height and highest point. Is this what we want to do? Yeah, and we only do this, let's see, lowest unreachable height. Why wouldn't that? Okay, I get it. Yeah, so highest point is the highest point we actually search. Lowest unreachable height. This one is still a bit of a... Like, we have seen it work in the experimental fluid simulation. But it's also a bit of a... It's not crystal clear to me. Not right now, at least. But it has to do with, so it's how we define overflow. So what we're afraid of is that we add water to a pool or a lowered area in the terrain, we fill it up, it overflows. These two helps with figuring out. Yeah, okay, so this is it. Highest point is the highest point we have that has water in it. Lowest unreachable height is the lowest point where we don't, where the water dries up, basically. We worked with fluid amount previously, now we work with fluid surface height, so we might need to rethink this one a tiny bit. But it's basically, so we want to get the highest point where we have water. If that one is bigger than this one, then we know that we're not overflowing, so we can fill it with based on highest point. But if we get a scenario where we fill up the water in such a way that it overflows and then it pours down and dries up, then we have a unreachable height, or we have an unreachable point. It's unreachable because the water dries up, and we want to take the height value of that point, because then we know that we shouldn't fill it up more than that. But the thing is, yeah, then we might get, yeah, we're probably gonna need to rework this a little bit, because I wonder here, lowest unreachable height, highest point. Let's just do a quick drawing and hopefully I can try and visualize what's happening. Let's zoom in. So if we have something like this. So we fill up here. One of these will be highest point. Then we fill up, it will be okay. But if we fill up like this water will dry up. And yeah, it will dry up here. What I wonder, however, So this one is the lowest unreachable height. In this very simple example, that will be the new fluid eventually. Because this one overflows, when we stop the process, it will dry up and settle at this point. But what I'm a little bit afraid of is if we have, let's say that we have something like, with the current implementation, and we have it goes down here and then up. So if we have this, so then this one will pour down here, it will start working here, and it will dry up here. So now this is our lowest unreachable height. But if we fill it purely based on that one, we will only fill this one like this, but we would actually be able to fill it like this. Unless, let's see. It's a question about these. This one we're going to simplify as well. Okay, the water fails. The height difference is 0. The neighbor height is bigger than M height. Final fluid amount. Yeah, I'm not so sure about this one. This might actually be a simplified way of doing it. Or actually, lowest unreachable height, it's this one, and then we have highest point, which is this one. No, it's actually, yeah, it's this one. Okay, this one is pretty straightforward. I think this one is good. So this one happens when we move in parallel. Neighbor height is bigger than m height. And it's the first neighbor. Or actually, yeah, we sort them here. That's good. Then we just set final fluid amount to n height, and that makes sense. So that's when we have traveled upwards and then we start drying up. That's good. So this one I'm pretty damn sure. But then again, height difference 0. Would this be triggered by this one? I think it would. That's not good. N height is bigger than m height. It's the first. Yeah, we're gonna have to rework this. Definitely. It's a bit unfortunate. Like if we get a scenario like this, we would like this one to be the new fluid amount. Maybe. I'm starting to think. Yeah, highest point. This will be the highest point. Yeah, and we want to check. Okay. Let's see. Unvisited points first. P height. We're gonna skip saving these things. Instead, I want to do. I want to simplify. We do. Fluid spread is bigger than some value. this one, I want to be able to compare let's worry about simplifying this later on. I was thinking about having this one as a separate method. So it would be n dot compare types or something like that, but we'll see. P height, we use P height here. Height difference. I'm still unsure about this one. Mm-hmm. Order by height, if I remember correctly. Mm-hmm. Oh yeah, we needed I here for this one, but I'm pretty sure we can skip this one. This check doesn't sit right with me. We're gonna have to worry about this one in a bit. So for now, let's do for each. if n water temporary is bigger or equal than water temporary, we use n height quite a lot. And this is how we do it now, so we do one thing actually. Water temporary, do we need to clear it? Or are we gonna assume that it's been cleared beforehand? Probably. Or actually, how do we do it in minima? Water temporary, we do clear data here. Yeah, we want to do that first here as well. I think. Let's move this one. Calculate stable fluid height would probably be a better name. Okay, so we have fluid spread here, and we want to calculate, we want to do this, if so we want to do this, and then we want to do checks, yes. Let's copy this one real quick. So we calculate the fluid spread amount, and then we check if that spread is bigger than water temporary. Then we set the value, and then we check if water temporary is bigger than height. Then we add it to unvisited points, but we want to do some more stuff here. do and this is where most of the logic will go, or the more important logic, the most important logic. Yo, what's up, Lombex? I saw your videos earlier this week. You posted a really good overview video on outlines. It inspired me a lot. Thank you, and very nice to hear. Good luck on your endeavors. So basically, this is all the logic we care about if the water dries up for some reason. Either we move upwards or in parallel. And it's going to be located here. I just want to make sure one thing. I think we want to do this one as well, first of all. So the first thing we're going to do when we loop through a new neighbor is we're going to see if affected points contains it. If it doesn't, we add it, because that means that we will alter the mesh. Definitely want to do this as well. Okay, so this is crucial that we get this one correct. So we set the water temporary value here. We check if it's bigger than height. If it is, we add it to unvisited points. And that's all we need to do. The only thing we need to care about is if we add water and it isn't greater than height, because then we know that the water has dried up, and we need to figure out how it dried up. Height difference equal to 0. This one is a pretty good check. I don't know about this one. I have to say it, you're recreating systems that have already been made elsewhere, in Unity or wherever else. Why? To understand them. Okay, but this video about making a creature collecting game. How are you doing today, man? It feels like you're extremely negative today, and I have no reason why. And like, if you think this system, like exactly the one we're doing here with the same constraints, have been made elsewhere and is available, be free to share it. But I don't think it's as accessible as you think it is. I mean, have you lost sight of your original purpose? No. I mean, developing like I've stated multiple times my vision for this game on this stream. So I would say that it's you like you don't seem to understand, or you don't seem to be able to like put one and one together. So if it dries up while it's moving in parallel, n height bigger than m height. The thing with that check is that we might have been moving downwards, and it might not no longer be true. Yeah, this is an early exit I don't want. Yeah, I don't know what he's on about today, Lombex. I don't know if he feels well. Yeah, but it's okay, but I worry for him. Well, it's good that all of these negative uh, negative comments comes from a good place. It makes them more acceptable, you know. Um, but I don't think I'm wasting time. Like, I'm growing, and I mean, I appreciate you, I mean, you've been here multiple times, and sometimes more positive than others. And I'm just trying to explain my point of view over and over and over. I don't think I'm wasting time. But okay, let's see here. We need to figure out when we have when the water dries up in such a way that it is a overflow. And This is like in our experimental implementation of this fluid simulation, this worked, but it had, like, we never got an overflow, but at certain water amount levels we got a non-consistent result. So we need to figure out how to make it more consistent, basically. We can start by doing, let's see here. So basically, if we have this case and we the water dries up here, we want to get this point. I wonder if you want highest unreachable point. Okay, so it dries up here. What data do we actually have from this point? We have height, and we have, or let's put it like this. We have height, and we have fluid at that point. Will that help me? Lombex, oh, this seems quite complicated to accomplish. Yeah, it is. At least for me. We do have a working solver. I just have to state that, but it comes with a few imperfections. And I want to make sure that we can, if we can iron out those imperfections, I would be extremely happy. And when it comes to voxels, not really. We're not really using voxels, but almost. Like, we're working with a grid. So we're working with pixels, but each pixel has a value of the fluid amount or fluid surface height. So one could say like we're basically working with a height map of water. I think that's the best way to put it. A height map of water. And we try to simulate that height map of water based on a height map of ground height. No, so it's a 2D grid. 2D grid. 2D grid. Like, if we would have worked with voxels and we would have simulated water, we might result in something like this maybe. So here we have a 3D grid with voxels, but what we're working with and what the result is, if I want to visualize the exact same thing, it would look something like this. So each position that is represented by a x and a y has a fluid surface height value attached to it. Like, I think our previous solution, if we got to this case with the previous solution, I think this one would only fill up to this part. While now we want it to fill up to this height. Oh, I see you're not counting depth then, since it's 2D. Don't exactly know what you mean, but let's say, I don't know if you have worked with terrain and height maps, but basically you have a texture where each pixel represents a height at that position, x z position, and that's exactly what we do with this water fluid. So, or water system. So we can always compare, so given a, I'm gonna call it, so given a x z position in world space, we can always figure out what is the ground height at that point and what is the fluid height at that point. Actually, I think this is much simpler than I initially thought, honestly. What the fuck? We just need, what, this is extremely easy, I think. If we add X amount of water to here, if we succeed in that without overflowing or drying up, if we succeed in that without drying up in a parallel, then that is our acceptable state. We try it again, succeed, and if we add this much water, it dries up, so then we just revert back to the, is that the fuck? Have I honestly How could I not have seen this earlier? Is there anything wrong with this? When could this fail? I guess it could fail. Depending on the iteration amount. Yeah, like depending on the iteration amount or the amount of fluid surface height we add per iteration, we might get a little bit of a diff here. So we should be able to add a surface height of this level. What's up, Enzo? That is simpler, but it won't permit for caves to be handled. But that's the simplest way to use 2D data. If you're not, yeah, we were not working with caves in this game. That would, like, every day I'm fighting to keep the scope small, so I have to get rid of some great ideas, and caves being one of them, unfortunately. But that decision was made long ago. Fuck, I'm pretty sure this is it. Run the iteration. If it dries up anywhere, take the previous fluid amount. The fuck. So if height difference is 0 and n height bigger than m height. Now we don't care about this. If height difference is 0, yeah, so if this one fails, and let's try this. Height difference is equal to 0. Can we do return false? And change this one to bool. This is our definition of drying up, so yeah. If it doesn't dry up, we're okay. It feels extremely simple. I want to try this, but I'm trying to envision what kind of problems this would lead to, but I can't really see it. If this works, however, I think we will be able to have one extremely big performance performance improvement we can make. Because like if we do this in iterations, that means that we have already iterated through a few points. We can just save those and set the values of those eventually. Or basically we could save. So whenever we exit here, we could store unvisited points and reuse them for the next iteration, but we do it with a higher... Damn, if this works, we can speed it up a great amount as well. But let's see, this is just like this is the inner workings of this phase. Calculate staple fluid height, fluid amount. What do we want to do? Check if fluid, or actually check for fluid overflow. It feels like I'm missing some apparent case that will make this not work, but I'm gonna keep my hopes up. Okay, so we find a minima, we get this minima while m is min. Okay, so when we get to this point, we know that we have a minima, and what we want to do then is we want to set byte fluid amount to be equal to 0 again. We don't need to redefine it like that, we just reset it, and then we do while I would like to do this insane thing here for now, or while I guess we can check for fluid solver token source token is cancellation, as long as we haven't canceled this one, we do this. And what we do here is fluid amount. Actually, do we need to move any data here? We need to juggle the data around, I think. So when we get back from this one, we have data in water. Actually, when I think about it, we might need to have a double check here, but that's okay. Fluid spread, if we add more water. Yeah, because we could also be adding more water here. And I'm wondering, I think we're gonna do this. So we always set water temporary here. Then we check if water temporary is bigger than this one. Or, yeah, because what can happen is yeah, this one can dry up. Fuck, I wonder about this one though. because like this, we add an extra layer of complexity here, because we also want to, like when we visualize this one, we want to get the affected end nodes around the water, the body of water, to be able to properly visualize it. But I wonder, okay, so if fluid spread is bigger than what we currently have, then we set the value. But then we do, so if water temperature is bigger than height, we want to add it to unvisited points. But I wonder if we only want to do this like, what I wonder is, let's try it with this one. Okay, so while we haven't done any cancellation here, I want to do, oh yeah, I wanted to check. So when we're done with this one, what we have is some data in water, which I'm okay with. It's okay, it's okay, it's okay. So, yeah, that is true. We want to do one thing in the end here. We also want to change the water levels to be able to visualize it. It's okay. But let's see. So, in here we want to do fluid amount plus equal to fluid unit. So this is how much we want to increase the water amount or water surface height for each iteration. I think the default is 5. Eventually I don't think we want to limit us to this. I think we're gonna put this at 1 to make for more gradual change. So this is what we're going to do first, and we're also going to define a float, or actually no, byte stable fluid amount. I'm going to put this one to 0. And then we do, can we do if await task.run? Can we do it like this? Check for fluid overflow, fluid amount. We want to send in the m.p as well, so the minima, the point where we're going to fill up from. So if this one returns true, we set stable fluid amount to be equal to fluid amount. And then we run this over and over and over and over again, incrementing fluid amount, like filling up. But we want to do other stuff as well. So here we move water, move data. I'm okay with this. Fluid amount here with the reachable minimas. Okay, so we might want to be able to quit this one as well. We might want to send in the token here, the cancellation token, but I'm not too sure about that just yet. But okay, after this we want to visualize this even though we might not have a stable state, because I envision that the character will start filling up a place in the terrain. The water will or the water height will grow, and then when we cancel it, it will either just stop where it is or dry up to its stable state. It can't possibly be this simple. Let's see. What temporary affected points add? Okay, so what I want to do then is okay, so no matter what happens here, we want to do await task.run. Might put these into this one eventually. We'll see. Recalculate fluid mesh data, affected points. Might also want to clear this one between this and this, I think. And then we want to do update fluid mesh, affected points, and finally await task delay default iteration time or wait time. Actually, find minimas. We want to put this one here and put this note here. Yo, what's up, DevSpires? Thank you, appreciate it. Have a great one. And welcome to all the new raiders, by the way. I can just quickly mention what we're doing at the moment. So for the past 1.5 months during the summer, we've been working on a fluid simulation with some very weird specific constraints, and we're now in the process of improving upon it, but not in a performance kind of way, but more about improving it in such a way that we can visualize it in a pretty way. Okay, so we do this while cancellation hasn't been requested, and I think this is everything we want to do. PG King, fluid simulation hype, yes indeed. Or I try to keep it hyped at least. To be honest with you, I'm growing I'm starting to become a little bit tired of it. I really want to deep dive into the water shader, but I want to get this into an acceptable place before we do. Okay, so yes, what I was about to say, PG King, is I'm growing tired of this fluid simulation, this part of it, but I'm starting to see the light in the end of the tunnel, and I really want to move on to making the water look pretty. I want to do some shader stuff. But okay, let's see. Right now, I'm just perplexed about the fact that I didn't reach this solution earlier. Like, if this works, I can't understate how simple this is. Like, as opposed to how complex I thought the system needed to be. But we'll see, we'll try it. Okay, so this part we only quit if we get a cancellation request, and we quit it in such a way that we know that these has already been done. And stable fluid amount here, we could do this in two ways. So we're gonna do it like this. When we cancel this one, we want to do some end stuff here. What we want to do in the final, or finally here, depends on this variable right here. So we need to be able to use this one down here. So we need to define it. We could define it up here. I think that might be the best. Stable fluid amount. So when we cancel this one, we have this one, and hopefully this is also one thing. We need this one as well, because so it's gonna be as easy as this. This part figures out where the closest point where water can pool up is. This part figures out how much water we can add to that point without drying up or overflowing. And finally, the final part is going to set the stable state of the fluid simulation. But I wonder, can we do this in a nice way? Is minima... Let's take a look at this one. Find reachable minima. We need to return the point. We could do it like, let's see here. P... So we set it to the start point, and it's not a minima unless we figured it out here. Yeah, let's go with something like this. Okay, so finally we need to check for two things here. Do we have a minima? If so, we continue to the other check. Do we have a fluid amount or a final fluid amount that is bigger than 0? If so, we have successfully added water and we can visualize it. If not, we revert back to the state we had previously. So it's going to look something like this. If m dot is minima and final fluid, what did I name it? Stable fluid amount is bigger than 0, then we have successfully added water. Otherwise, we're going to do something else. The otherwise is much easier. Then we just do terrain. We're going to do it like this. So here, water previous contains the water state before we started adding water to it. Water contains the current state of our, or the current visual state of our fluid simulator. So what we do here is we swap these two channels, because then we can visualize it real nice in a shader, like we can lerp between water previous and water. We're also gonna have to add, I think, or actually we can do this. Add fluid async to do add timestamp logic data. The timestamp channel of the sole purpose of the timestamp data is just to be able to interpolate. So when we add water, I don't want to have these iterative additions. Like I don't want it to pop from one height to another. I want to continuously lerp between those two values. Just make it a little bit prettier. But the more important part is this one right here. So we have a minima and we have a stable fluid amount. And basically what we want to do then is just something like this. But is it insane to start a new task here? We're gonna do it either way, actually. So basically what we want to do is this last step, which is pretty straightforward. So we're going to go private void update stable fluid state. And I guess we want to send in a terrain fluid point P, and we want to send in a byte fluid amount. question here. Do we want to work with water temporary here as well, or do we want to work with... No, I think we can work with water. So we want to do this. P. I see a lot of performance improvements we can do. I don't think we need to do this. Every affected point should have already exist in affected points. Let's take this one. Okay, we can't use P. I want to use P here, so we're gonna do, let's call it M, because it is actually the minima. And I just have to check this one, remove at. For each n in get neighbors p, we do p dot get neighbors. We don't care about sorting them this time around. Calculate fluid spread amount. So this is what we're gonna do here. This is a little bit different, I think. Actually, yeah, let's take this one. Fluid spread. And here we just do fluid spread, calculate fluid spread amount from P to N, but it's gonna be free. So even though we move, actually, one sec. Yeah, even though we move, this might fuck it up. Yeah, it will. This is the point which explains why the previous step isn't as easy as I thought. Definitely. We can still implement this one, but we're gonna have to make some changes to the previous step, I think. Fuck. Or let's put it this way, we can simplify it in such a way that this actually works, I think. Because what I'm worried about is a case where we do... If we add water here, we're gonna move like this, and here we start drying up. Actually, and then we dry up here, so it doesn't work. So we get the previous one. Let's try it. Maybe. Yeah, okay, it's going to work, I think, because like the stable state we have calculated is a stable state with a, we know that we reach an end state even though we dry up the water. So doing this without drying up the water will definitely result in a stable end state. because we loosen constraints, we don't add more constraints. We want to do this. And we want to do this again. But we don't want to work. We don't want to work with water temporary here. We want to work with water. And if the water level is greater than the height, then we add it to unvisited points. I'm a little bit worried about this one. I'm still afraid of the fact that we might be adding neighbors to unvisited points multiple times. And I don't like that. Yeah, I think we will. Nah, this one should fix it for us. But we have a problem here then. Just gonna take this one first of all. Or actually one, yeah. We need to check this. Yeah, this is one thing I'm a little bit scared of. So, fluid spread can be more than what we currently have. But this one can still be true, and this one can be true. Okay, so how do I want this check to flow? Fuck, am I gonna have to do the same check twice here? Basically, the water dries up, but it dries up so much that fluid spread is not bigger than the water temperature we have at that point. And let's assume that that point already has some water in it but the water height is still lower than ground height. We definitely only want to set this one if it dries up, or if this is true. We only want to do this if this is true. I want to do a check like this. Maybe the flow isn't the best, but height difference is 0, and n dot get value, terrain data type, water temporary is less than. Oops, this is a check we want to do here, I'm pretty sure. Let's keep it like this. Where do we have our issue? Down here, right? thought it would be around here, but why am I not seeing this? Yeah, it is. Okay, we're missing. Yeah, there we go. Okay. Yeah, we want to do a check here as well. If get value terrain data type water is bigger than get value height, then we add it. But we can do this check within here, I think. Okay, do I dare test this? Water. Yeah, there's one thing we want to do. Let's see here. Yeah, we swap these. I wonder, do we want to do it for... Yeah, I'm thinking we want to do this. So we swap it back to how it looked previously. Then we don't need to do anything here, but here we want to do await task, run, set stable, or what was it? Stable, update stable fluid amount. We want to send in m.p, and fluid amount is stable fluid amount. When that one is done, we want to do this. So either way, then we want to do this, then we want to do this. Okay. And then we're done. Okay, I want to try this. I want to try it. But this one works. I don't know. One sec. When we do check fluid overflow, we do it in water temporary. Great. Yeah, let's skip this. We can skip highest point as well. I hope. Height difference and height, we only use this one here. Return true, return false. Fuck it, let's see what we have. I forget to do something? So finding minimas. That's what we're still doing. Actually, did we finish find minimas? Then we restart. We set fluid amount to 0. Check for fluid overflow. Are we running this one forever? Or actually, we don't have any more prints here. But we should still be seeing some visual change. Let's add some prints. Yo, what's up, No Scope? Just wanted to thank you so much for that outline shader video. It helped me a lot. Nice to hear. It's also available on GitHub. Don't know if you know. I think the link is in the video description. Oh, ooh. Nah, I don't know why we're not getting a result here. Definitely want to get to the bottom of that. Yo, what's up, Robert Pattinson? How are you doing today? Thank you for the raid, appreciate it. And I hope you had a wonderful stream. No Scope, yeah, I know. I spent like 3 hours just copying from your video, then realized you had a project on GitHub. Hopefully you learned something on the while copying from the video at least. Robert Pattinson, I had no stream, I just started a stream to raid you. Okay, I still appreciate it. Okay, so why are we not getting a... I think this one might be running for ever. And I don't know why. Oh, one sec. No, it's probably not running for forever, but we need to do one last thing here. We clear data, unvisited point, we do all of this. We always set water temporary, but we never do anything with water temporary. In the end here, I want to do we want to move whatever we have to water. So we pretty much want to do this part. So this is for finding the minima. We want to do this part. Or something similar. We don't want to do this, definitely not this. I think we just want to move whatever we have in water temporary, we want to move to water. Just straight up. So I think we can do check for fluid overflow. In the end here, we do environment controller move terrain, move data, source, What the hell am I doing? Water temporary to terrain data water. Here we actually have a reset source which we can set to true, which means that we don't need to do this one every iteration here. But we're gonna wait with that one. Move data water temporary to water. So we spread the water, but at the same time we try to figure out if it's stable or not at the same time. One sec though. We might not want to exit early on this one. We might want to finish all the neighbors before we exit to get a better visual result. I think we do. So we're probably gonna do while bool stable state is in stable state true. And then we just return is in stable state. Okay, let's try this. So we have two changes, one being moving water temporary to water, and the other one being letting the finding of a stable state run longer than we initially did. I don't know. Interesting. One thing. I'm still a little perplexed that we don't get a visual result here. So what happens? We start by resetting this one. This one is reset, so this one should be true. Oh, yes. Of course. We're not doing the initial add of water to M. So we pretty much clear water temporary, and then when we get to this one, we calculate the spread. We do it by using P dot water temporary, but that one is 0 because we don't do this one. We need to set the initial value of P as well. We need to like define the start state. It shouldn't be harder than just doing this, I think. I'm pretty sure. And right now this fluid simulation pretty much assumes that we don't have a previous stable state, we just have empty water, and we're gonna have to fix that as well. Don't think that would be too much of a problem, however. Okay, so we clear this one and then we do this. So we add water temporary that is equal to height plus fluid amount, and then we run through this one. I think we need to do something similar here as well. So we do a... One sec. Is stable state. Yeah, if stable fluid amount equal to fluid amounts, we need to do something similar here as well. We're gonna do, but in this part we just do m dot set value terrain data type water Okay, let's try it. And depending when I cancel it, let's cancel it here. Is this actually a stable state? Yeah, it is. Okay, that's fucking beautiful. So what would happen if I do height? Oh. And then we do this. And we add water here. And then we quit. think this is a stable state as well. I want to try it. Oh, that's great. I want to try it with it's okay, same, and there we go. And then we do water. Let's add it here. Is this? The increment is extremely small. Thought it would be greater, but if we do start overflow and then I quit, we don't get back to the stable state. We don't successfully exit it though. I think we're still running it. Oops. Because this is definitely not a stable state. Okay, so a few things. Should be okay. Yes, okay. I know what the problem with the visualization is. I think. The problem now is why we don't revert back to environment control terrain swap data channels, water with water previous. But I don't know why we're not reverting here. We should be able to do this, I think. Or could it be that we need to do it? Check for fluid overflow. Yeah, I don't think we can do it exactly like this. Let's just double check and go to task C sharp. Don't we have task egg, task bacon? I wonder if we need to do this. Damage result. So we just return damage result, calculate damage done. And we do a weight. I wonder, do we need to do it like this? I don't think so. Actually, yeah. Prepare data, find minimas, check for fluid overflow. Ooh, and this one is extreme. The last one is extremely quick. I wonder why. Do we pretty much leave it as... Yes. Yes. We need to do the same thing here. So this, but we set value. Now we do that. What the hell? But yes. Now it should be okay. So at the end of check for fluid overflow, we move it from water temperature to water, and that is okay. And before we start the last one, we move it from water to previous and previous to water. That's good. But I wonder if... Now we only have it here. We only do the cancel check here. But... Ooh. Yes, we know we need... Nah. Yes, we need to throw this one as well. Or do we? Yeah, we do. So basically, yes. Okay, so when we set this one to true, we just exit this one, we skip this part, and we do this. We don't actually enter finally. We do it like this because we might want to do some extra setup here, but for now we're just gonna do it like... Fuck, I don't know if we can do it here. I don't know. Yeah, this might be a weird way to do it. Okay, I want to test if this is the issue, so we're gonna do a wait task. Can we do delay int max value? Extremely ugly way to do it, I think. Can we do it like this? So the next time we get here, cancellation is requested. We send it this token, it's already requested, so hopefully we will exit. We do exit. The question is this a stable state? We iterate here with a very small amount. Not a big fan of that. We're gonna fix that soon. We continue. Let's see. Terrain fluid. Prepare data, find minimas, check for fluid overflow. We do this for a very long time. Then we do update stable fluid result. I don't think we need to do this, but would a better way to do it be this? wonder if this one even cancels it. It should be. We jump down to this one. We do. Move data water temporary to water. Yeah. I wonder if we might need to add an extra exit to it. Because if we do this, change to water, we add here. Okay, this works. But on the other hand, if we do this, we start filling up here. Okay, now it's stable. Now we have to wait. I really need to speed this one up. And we're gonna get some overflow soon. There we have an overflow. I quit. And we get this shit. Fuck. So the water here. We don't. Oh shit, 1 sec. Sorry about that. Okay, back. So okay, we don't revert to the stable state for some reason. And I want to figure out why. Is it because our stable fluid is wrong? Oh, or is it because this one doesn't really do its job? Okay. Before we enter this one, water should be water previous. So if we have added water... But my question is, water previous... Check for... Does this one... Yeah, we do something with water, but not water previous here. So it should be okay. Only water temporary and water. Could it be we moved data from water previous to water, but we also this one is okay. Yeah, I don't see it. I wonder if this one somehow screws it up. if there's something else. PG King, out of curiosity, since when have you been working on this project? Do you have an idea of time or how long it will take where the basic gameplay will exist? I actually answered that question earlier on today's stream, but I can do it again. So at the beginning of 2021, I started writing the first lines of the design document. Yeah, it's no problem. Like, I have nothing against saying it again, so nothing to be sorry about. But at the beginning of 2021, I started writing the design document, and I also did the first devlog, just talking about what the game will be. And at the end of 2021, I wrote the first line of code. And then I worked on it on and off, not that active, but still achieved some stuff like the outlines and cell shading and character design and whatnot. And at the end of last year is where I really started to put more time into it. At least 4 hours on weekdays. So what is it? A little bit more than 3 years since I started writing the design document, and a little less than 3 years since I wrote the first line of code. And when it comes to the second question, like, I don't have any hard deadlines for the game, but I have a hard deadline for my first vertical slice. And that's going to be, I'm aiming to release a vertical slice of the terraforming system or the garden system at the beginning of next year. Yo, what's up, Mimi? It's going pretty good, I think. It has been smooth sailing up until this point. Now we have a little bit of a issue I can't seem to find the cause of, but it's going good. What do you mean by vertical slice? So if you visualize your game, the full complete game, as a bread loaf, and then you take a slice of that bread loaf, so it's basically a part of the game that is fully playable and fully polished as it should be in the end. Maybe not the best description. Slice. We could do game. A fully playable portion of a game that shows the developer's intended player experience. I think this one is a pretty heavy point of a vertical slice. So when I say a vertical slice of the it's basically a vertical slice of the game, but it's only the terraform part of the game. So I want to have that out at the start of next year. So that means visually acceptable terrain, dirt, grass, trees, bushes, rivers, and stuff like that. And I would also like to aim for, like, the gameplay. Like right now when I'm developing this game, I just run around and click on a spot on the terrain and that terraforms it. In my garden vertical slice, I also want to have the gameplay for terraforming done. So it's basically going to be not really a quick time event, but sort of. So we're gonna have, like, the character pulls up a shovel, you choose the correct spot, the player You have to stand at that spot. We will have some small gameplay concerning that one, and also animations, dirt flying, whatnot. Will it be a fixed environment that you put in yourself, or generation all the way? I'm gonna design the initial look of it, and then it's up to the player to do whatever he or she wants with it, basically. So I think I'm gonna design it initially as a landfill. Is that the correct word? The correct English word? So it's basically gonna be a garden that no one has taken care of forever. So just a big pile of dirt and trash and stuff like that. And then the player can make it look nice, basically. I think it will be real nice. The reason I want to get a vertical slice of the terraforming or the garden out is because I want to get input. Like, I have this vision of how it should be played, and according to my vision, it will be fun, but I need to make sure that it's actually fun. I don't want it to be tedious for the player to alter the garden. No problem at all. I love answering questions. Same questions as well. I'm a little bit worried about this one though. Why? Water previous should not be altered more than it should be okay. Or one sec. Here we actually do. We move water previous to water because we want to visualize it. And we can actually quit here. No. Here we move water previous to water. Oh. This one. We might actually fail here. I wonder if this is the cause for the problem though. Nah, because we shouldn't be altering water then. So if we cancel this one, yeah. I don't know. Set value water. Let's see. Let's do, when all else fails, let's do some prints. Update stable fluid result. And then we do this, and we add final fluid, or stable fluid amount. Let's see what we have for stable fluid amount. Very interested in this one. Yeah, now we're gonna have to wait again. I need to fix that as well. But we find that minima, we fill it up. Very small increments. And then it starts overflowing and we exit and we get 140. Yeah, that's wrong. 141. Why do we get a 1 here though? We're filling it up with 140, but we eventually have 141 here. Okay, first of all, 140 is wrong. We should be getting, or we should be getting a result of 120, 28. 128 would be nice, or something like that. Am I missing something? $140 and $141. Well, this definitely means that this one always returns true. Oh, whoa, 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 whoa. Fluid amount, we reset it to 0 here. So we never actually set it to false. Height difference P minus N. This one should be equal to 0. And I get it, I get it, I get it. This one is never true because these two are equal. We stop when these two are equal. So I guess we want to do this in this check. Let's try this. So yeah, the water dries up and our dry constant is 1. Oh yeah, I get it, I get it. Our dry constant is 1, so when we move one step in a parallel fashion, we take the fluid spread is whatever fluid P has minus 1, and that is the same height as N, and we don't get and that doesn't flip the Boolean, but it stops us from going further in that iteration, I think. Let's go minus 0.3 here. Something like this. Please. And we start filling it. And then we start overflowing, and then we quit. And then we get it. Beautiful. It took a little bit of a it was pretty quick. I wonder. Okay, if we want to make it quicker, we can also make sure that we can check for fluid overflow. We want to be able to exit this one while we're doing it. So we want to send in the token as well and handle the exit in here. Because right now, if we notice that we're overflowing, this one keeps counting. Or if we cancel it, this one finishes, this one finishes, this one finishes, and then we get to this one. So yeah. Okay, but this is great. An extremely simple solution as well, I would say. Then we quit there. So I think we can do, if we start here. Oh, that went a little bit too quick. Beautiful. Oh, great. And then I think, I'm not sure if this is the best choice, but like the interpolation between states, which is incremental here, looks pretty bad. We're gonna solve that one by, oh, beautiful. Beautiful, beautiful, beautiful. We're gonna solve that one by shader interpolation, I think, or interpolation in the shader. Definitely want to make this work as well with, so if we stop here, we get this little pool of water. If we add more water here, right now the solution doesn't work with what we already have in place, so it will look something like this. So when we find the minima, we want to calculate how much water do we have in that minima, or the water amount we add is going to be dependent on the water amount we have in the minima as well. Okay, fuck, it feels great finally seeing this one working. So if we try here and we exit, then we get 0. Beautiful. Okay. Oh, we're so damn close to starting to improve the visuals of this water. Can probably do it next week, honestly. Or the week after. Love it. Can do okay. I'm gonna have to quit soon, so I'm not gonna be able to start working on making it work with already added water today. That's what we're gonna do at the beginning of next week. But this one can still do with a little bit of cleanup and one more thing. Oh, I just thought about it. What? Let's see if it comes to me soon. Okay, so let's exit this. Go down here. I think we have a few. Calculate spread to neighbor. Spread fluid to neighbor. Calculate spread. Then this one we need. Then we have get neighbors. We don't need this one anymore. Update fluid mesh. Recalculate fluid mesh data. Finish step. This one we don't use anymore. Okay, that's pretty damn nice. So a threaded terrain fluid solver in sub 300 lines so far. Yeah, the final solution, so like checking for fluid overflow, turned out to be extremely simple if you do it like iteratively like this. Who knew? Okay, we have two things I want to fix before we, or let's see here, on Monday when we continue, I want to fix keep visual finding minima. Let's see, keep finding minima visuals when moving on to next step. So when we initially add water, you can see this little bit of line of water flowing to the minima. And then when we start calculating non-overflowing amount, that one gets removed. I want to keep that one while we increase the water surface height. So that's the first thing. And then we have make terrain fluid solver work with previous water. Oh, and let's see here. Improve overflow finder such that the water let's see here. Improve overflow finder such that the water, or such that all the points get a fixed amount of water, I think. Or actually, yeah, I'm a little bit, or actually, I need to double check. So like when we fill up, like the iterations, it seems like it's filling up slower than it otherwise would, but maybe not. So for instance, if we take take this one, then we take this one. How many iterations do we actually have here? Do we have 29, 55? No, it actually fills up in increments of 5, so that's good. Okay, beautiful. And there we could see one of the issues with this one. We had a flicker of one extra step being visualized, and that's because we cancelled the task while this one was running. And so this one finishes, jumps down to this one, finishes it, jumps down to this one, finishes it, and this is where we move on to finally. So improve overflow find such that yes, keep finding minima visuals when moving on to the next step, make terrain fluid solver work with previous water data. Before that one, I'm gonna do make check for fluid overflow. Make it possible to exit early. Okay. And that's already done. Yes, I'm gonna add one last task, which is going to be, I just want to add this one for like far future, because right now the speed of which this one runs is not the best, definitely not, but it's okay. So we don't really need to improve the I don't want to put too much time into improving the performance of this one just yet, but there still exists multiple points in here, or multiple places where it would be pretty straightforward to improve it. Definitely. So when we do the iterations, instead of starting, like, we add 5 fluid amount to a point, and then we grow it outwards until we dry up or find a stable state. If it dries up, or after that, we increase the amount, and then we walk out from the very same point. Instead, we could just keep track of where the endpoints are, add the fluid amount to those, and start walking out from those. So improve performance by minimizing duplicated calculations. Pretty much. But then again, yeah, I think we can do it pretty easy. But all of these tasks is gonna have to wait until next week, because I gotta run. But just to summarize today's session, I think it went pretty great. We're pretty much done with a threaded fluid solver that always results in a stable state, and which is split up into different parts, and all of the different parts are, or can be, very roughly visualized. So I'm happy with that. But yes, like always, thank you so much for watching. Hell yeah, PG King. Hell yeah, indeed. But like, as always, thank you so much for watching, everybody. Appreciate it, and have a great weekend. And hopefully I will see you Monday. Peace.